Tonight's speaker, Alexis Troschinetz, comes to us from CERT. Most of you have already seen her bio, so I'm not going to read it, but I'll leave it on the screen for those that are watching on YouTube. Note that CERT is short for Clean Energy Resource Teams. They were launched about 20 years ago, and they connect people in our state with technical resources to build a clean energy future. So what are heat pumps? I bet a lot of you know. Is there more than one type? Do they work in cold weather? Are they viable for your home? What should you do first? And how do you select the right system? Tonight, Alexis is going to bring us up to date on the basics, and she knows a lot more than that. So this is your chance to get your questions answered. So Alexis, welcome to the meeting. Go ahead and share your slides.
Thank you very much for having me tonight. I'm excited to talk about heat pumps with everyone. The efficient electric heat is on, so let's talk about it. For those of you, Tim said a little bit about us, but I've just got two slides about CERTs. We help Minnesotans build clean energy by connecting individuals and their communities to resources they need to identify and implement community-based clean energy projects. And so clean energy for us includes not only energy efficiency, but renewables, electric vehicles. We've even dabbled in a little energy storage. But these are our 7 regions, and we really do work across the state. We have staff members located in each region helping to do projects on the ground. And we help folks with hands-on assistance. We love giving practical steps on clean energy, presentations like this, and learning opportunities like our resource guides. We are a partnership of 4 organizations. So I actually work for the University of Minnesota Extension, but the State Energy Office, the Department of Commerce Division of Energy Resources is one of our partners, the Southwest Regional Development Commission, and a nonprofit, the Great Plains Institute. And here's our website down here, because a lot of what I'm going to show you tonight is on our website, including much of what I'm sharing tonight comes from this air source heat pump educational guide that CERT's put together. And so that's just our website /ASHP. And I'll just start off in case folks aren't aware, but heat pumps go by a lot of different names. It could be mini split or ductless, might be some other names you've heard. And then within these, there's all sorts of, even more jargon around it. And then, I'm talking about air source heat pumps only tonight, but there's still geothermal or ground source heat pumps out there as well. And then the other thing that can, folks have kind of thought of like mini splits for air conditioning, because that's been their most common application, say in the Twin Cities up until now. In homes with radiators, people were getting mini splits for cooling. And so now we're trying to make sure folks are aware that those can provide heating too, because they're just an air source heat pump and they can work in both directions. And that heat pumps, even though it says heating in it, can provide cooling. So it can be both. And how do air source heat pumps work? They are essentially an air conditioner that can operate in reverse. They efficiently heat and cool with electricity only. And we're turning to this technology because it's much more efficient to move heat rather than make heat. So some of our traditional heating, forced air furnaces are burning a fuel, and they're making the heat right there, whereas this is simply harnessing heat from outside air and using a heat exchanger and some air handling to bring that heat value from the outdoor air inside. And in fact, you can provide up to 3 times more heat energy into the home than the electrical energy that an air source heat pump uses. And that is just through physics, compressors. If you're wondering, how can that be? I like to tell folks that's like a vending machine. You put $1 in and you get, 3 units out. And why are heat pumps so important in Minnesota now? I'll get to how the technology's improved, but boy, we have a lot of heating hours in Minnesota, 2,000 heating hours every year. And we've only got about 300 hours of cooling, meaning these are the hours our equipment needs to run to keep our homes comfortable. And as you can see on the right, in Minnesota, heating and cooling make up much more than half of our home's energy use. And the more efficient we keep getting on these other topics, you know, the greater and greater proportion is left to just heating and cooling for us to make more efficient and cleaner. And I'm going to get into appliances a little bit too today, and water heating. So we're going to kind of cover some of these three biggest energy users in the house. Air source heat pumps have come a long way in just the last few years. So there's kind of a generation ago that was used a lot for air conditioning, and they operated down to about 30 or 35 degrees. Well, now we have cold climate air source heat pumps, and they operate efficiently down to 5 degrees Fahrenheit. And they're operating efficiently. They're not just running, they're actually performing really well at that temperature. And the DOE is carrying out a technology challenge right now, where they're challenging manufacturers to optimize their equipment for 5 degrees and all the way down to negative 15 degrees Fahrenheit by 2024. So pretty soon we're going to see some even more capable equipment. And so here you can see that I say you'll want to keep a secondary heating system. And that's because we do get colder than 5 degrees here in Minnesota quite a bit. So we want to have that secondary heating system to help us out when it's getting a little colder. How can heat pumps in Minnesota work when it's cold? We all know it can be colder, and the difference between cold and colder is actually still heat, a heat value that we can pull from the air. So I kind of explained it a little bit earlier, but this is, bringing that in and helping with that heat exchange through compressors. And there's two basic options for system setups. You've got your ductless or mini split system, where you have an outdoor unit that's kind of got its fan on its side like that. And then you'll have multiple indoor units, usually mounted on a wall, but you can, there are versions where they look more like a radiator down on the floor for the indoor unit to provide the air handling and bring the conditioned air into your home. And then there's a central or ducted, and that looks more like your typical air conditioning outdoor unit. And then that connects to your ductwork like your air conditioner already has. And so for ductless or mini split heat pumps, like I said, these can be used in homes that don't have any ductwork. And some benefits are that you can have zoned heating and cooling, which means you can kind of only condition the parts of the house that you're occupying. The cost can vary greatly if you're just kind of doing the most basic system of only one outdoor unit and an indoor unit. And this lower cost, I would say, is a little bit more of a greater Minnesota cost, not a metro cost. In the metro, that might be more like $5 or $6 grand for just one of each. But typically, if someone's gonna, go for this setup, they're gonna have maybe up to 3 indoor units. And so that's gonna get you up into this, 10, 12 or higher $1,000 project cost. And this is a really good fit if you have radiators or in-floor heat or electric baseboard heat. And if you are currently using window AC units and you want to, get rid of those or add cooling for the first time, the mini splits are a great option. And then the central unit is what you would use if you have existing ductwork, and you can connect into your indoor furnace's fan. And you have to just kind of work with your contractor about compatibility. If what you have indoors will still work with a brand new unit outdoors, or if you might need to upgrade the fan motor and that equipment as well when you do this conversion. And this installed cost has a little bit of a tighter range of $4,500 to $15,000. This is a great fit if you have forced air, and if you're replacing central AC, you're getting it for the first time. And like Tim said, I'm kind of also assuming most everyone on the meeting tonight heats their homes with natural gas. And so in that case, you might really be considering considering a heat pump for a little bit of heating offset, and I'll get into that on the economics, but also for air conditioning might be your primary use, and then using it a little bit for heating. And so in that case, you've got options. You could go anywhere from a single stage heat pump on up to a variable speed heat pump, all the way to a cold climate heat pump. Think of that as a spectrum, but know that you've got some options there, especially these all have different, price points. And CERTs, we've featured other Minnesotans and stories on our website that have adopted air source heat pumps. Got some folks up in northern Minnesota with, wood burning and electric baseboard heat. And then on the right, we've got a family that went all electric in St. Paul, Minnesota, and you can hear all about the steps they took in their projects. They also did like a clothes dryer, water heater, all the electrification they could do to disconnect that gas line. And then on the left is another staff member of CERTs in central Minnesota, and she shares a real honest, view of how it's been working for her, like remembering to clean the air filters, some more tangible thoughts like that on heat pumps. And from the stories we've been telling and just our work over the years really now on air source heat pumps, we've been hearing these two things from people about what's concerning about switching over to air source heat pumps and what's appealing. So what's been concerning is a little bit of that contractor availability, and I'm going to have some resources to show you about that, and how much contractors are aware of this cold climate capability that air source heat pumps have now. Folks are of course concerned with the high upfront costs, but I will get to share with you tonight about Inflation Reduction Act incentives that are available now and coming. Folks can be a little uncertain of bill impacts, and I'll talk a little bit more about the economics next. And then there's this tying multiple systems together. How are they all going to work together? We're going to have a remote control for one and the thermostat for the other, and kind of trying to reconcile all of that with the contractor, make sure you're happy with the system that gets installed at your home. Electric panel capacity is one more topic on folks' minds. Whether it's they've got enough there to electrify more of their loads. So pretty much if you already have a central air conditioner, you won't have a problem adopting an air source heat pump. It requires about the same draw. And so that's not a major concern for most homes in the metro or greater metro area. Of course, the idea of lower bills, but I'll get to that. That's only guaranteed in like areas of the state heated with propane or all electric heating homes with electric baseboard resistance heat. Folks are really liking the dehumidification because it runs a little more low and slow. It's able to dehumidify much better than conventional air conditioning systems have. It's a very steady comfort, and there's for the energy efficiency aspect, you actually need to shift your mindset. We've all gotten used to setting back our thermostats to be more energy efficient. Well, with an air source heat pump, you actually want to set it and forget it for the most part. Keep it at a more constant temperature and it will operate most efficiently. Folks are, of course, interested in it for increasing their home's efficiency or maybe even fully decarbonizing their homes. Very quiet operation. And then right now, I put big utility rebates here, but more money is coming and kind of showing us that, the resources are being put into this technology, and it's for good reason. And there'll be quite a bit of opportunity to offset the high upfront costs. So homes with natural gas heating, we can expect an energy savings overall, but likely not cost savings on an annual basis. And that is if you're trying to heat it entirely with your air source heat pump, your home. So in that case, still using natural gas, through the deep part of winter and the coldest part of winter is what would be most economical. And I'll have some graphs here in a minute. But folks might consider air source heat pumps for other reasons in natural gas territory. Maybe they're working toward a net zero or all electric home, or they're just looking to add or upgrade their AC and want to go with an air source heat pump for having that little bit of electric heating capability. So this comes from the Minnesota Air Source Heat Pump Collaborative, and it's funded by a handful of utilities in the state. And the whole aim of the Air Source Heat Pump Collaborative is to help this market come to be in Minnesota. And part of that is contractors. So I'll be sharing another resource from them later on contractors. And this is actually a tool that they have on the contractor side of their website. If you go to look for it, it would be under the contractors resources. And because it is a little complicated at first glance, you're kind of like, whoa, what's going on with all these bars? But this is basically a cost comparison of a baseline conventional system, a forced air furnace and air conditioner on the far left, against all electric solution on the far right, and then different temperatures at which you operate the two systems, say your natural gas furnace and an air source heat pump together. So I'm going to take this chart bit by bit here. So let's say your goal is to be all electric. This would be the greatest carbon savings, and this would be your cost picture. You're looking at 30% more in costs that you're spending on heating and cooling in an average annual year. And then let's say that you wanted to maximize the use of the technology. So this means you would get a cold climate air source heat pump. Make sure you're going all the way with the Cadillac version, the most capable. And here again, you would be looking at just a little bit of offset still with your natural gas furnace below 5 degrees, and still looking at a cost premium. But now if you were looking to break even economically, that would be close to this 35 degrees switch over. So that's a weird term, but what that pretty much means is at 35 degrees and above, you could heat your home as long as everything is sized properly, installed properly, functioning well, with the air source heat pump alone, a cold climate air source heat pump alone. And then below 35 degrees outside temperature, you would switch over to using your natural gas furnace, and that would give you the most favorable economic situation. And this chart here shows that, how many hours you'd be running each piece of equipment at that 35 degree temperature. So you would be running almost 50-50 still. So 53% of your whole winter season's heating hours would get to be covered by an air source heat pump, even running it at that economic break-even point. That's pretty great. So for the next steps for heat pumps for heating and cooling, you definitely want to tighten up and insulate your home before you make any major change to a heating and cooling system in your home. So even if you're going for a new furnace or AC, I still would recommend tightening up and insulating your home. And if you aren't sure what that looks like for your home yet, starting with a home energy audit is a great first step. They'll let you know how much you need and all of that. And many of you might be in territories that are served by Home Energy Squad. And that would be my recommendation, is to start there if you're a CenterPoint and or Xcel Energy customer. And that'll get you started down a really good path for getting your home ready for electrification. And then you can kind of check out your electric utility rebates and just confirm that you've got some money there, and start getting bids from 2 to 3 skilled contractors. And then also keep in mind Inflation Reduction Act incentives, and I will get to those in a minute here. About the contractors, we now have a great resource for that in Minnesota. It's the Preferred Contractor Network from this Minnesota Air Source Heat Pump Collaborative. These are folks who have been trained specific to Minnesota's climate and about cold climate air source heat pumps. And they've also been trained on quality installation and have even had a site visit to one of their installations to confirm quality installation. So it's a very great listing, very quality listing. And if you don't see someone listed there, you're welcome to reach out to me, and I might have a couple other recommendations for you. But being in the metro area, you'll see that there are a good handful of options on that list to start with. And these are the kind of questions you can, ask a contractor once you start working with them about a cold climate air source heat pump or heat pumps in general. And those are available on our guide and website as well. So I'm going to step out to the whole home now for just a minute and talk about some other equipment in the home. I've been talking about this a little bit in terms of, people are interested in having an electrified lifestyle. They want the EV, maybe some solar panels, so some other home equipment that might go well with that for heat pumps would be a heat pump clothes dryer and heat pump water heaters. So I'm going to talk about that. And we do want to keep thinking about what it means to electrify. If we're electrifying, we want to keep in mind that we're trying to beneficially electrify, not just simply electrify, but do it in a beneficial way. And so this is what beneficial electrification means. We're saving consumers money over the long run. We're enabling better grid management on the whole. So we're not creating a lot of new load during times that the grid is already congested, they call it, just like traffic. And we're reducing negative environmental impacts. That's what beneficial electrification is. So for heat pump clothes dryers, there was a study completed. The state funds research projects on different types of technology with energy savings or different approaches. And this came out of that, this and the next study, I think, were both funded through the State Conservation Applied Research and Development Grant. And with heat pump clothes dryers, we're looking at when we switch from an electric clothes dryer, on all electric clothes dryer, to an air source heat pump, we're seeing 20% savings if we've got a full size dryer, or 60% savings if we've got more of that compact heat pump, all heat pump dryer. So a hybrid dryer has a electric resistance in it, and you can kind of turn that on just like it becomes kind of a electric dryer if you need your clothes dried more quickly. And in this study, they were trying to understand how much of a hindrance it might be to have that compact all heat pump dryer. And they found out in their pre-study that based on the weight of the clothes and everything, 95% of the loads, just following people's normal practices, could be dried just fine in a compact dryer. So it's a little bit of a longer drying time. And there aren't as many utility rebates for these right now. And they are best paired with an energy and water efficient dry washing machine, because energy and water efficient washing machines like get a lot of the water out of the clothes before they go into the dryer. Heat pump clothes dryers are gentler on clothes due to the lower temperature that it's running at. You have the potential to remove dryer venting if you'd like, and that can cut off basically one more source of cold air coming into your house as well when you get to do that. And they do cost a little bit more, $400 to $600 more than conventional electric dryers. There hasn't really been a solid study done in Minnesota anyways on natural gas clothes dryers compared to heat pump clothes dryers. For heat pump water heaters, again, this is comparing an electric water heater to a heat pump water heater. And we're looking at about $200 savings in per year, or 6 years payback, meaning that energy savings are going to help pay for that cost difference in 6 years. And these do require a little bit of space because, as we were talking about earlier with air source heat pumps, they're harnessing the heat energy from the air to put into the usable heat, in this case, heating the water. So you do need this to have about 1,000 cubic feet of air space to draw from, and that means they're well suited to be placed in basements or mechanical rooms that are adjacent to conditioned areas, but not so much in closets like you'd see in apartments or mobile homes. Wherever the heat pump water heater is placed, it's offering a little bit of dehumidification, maybe not enough to solely rely on for your entire basement's dehumidification needed all summer, but it helps out a little bit. And these are quite a bit more expensive than electric resistance water heaters, $1,500 more. And now I'm going to talk about the money that's available to help with these projects. The Inflation Reduction Act came through last year at the federal level. And I'm going to kind of walk through the ones that are relevant to heat pumps, and you'll see a few others, but we've got tax credits, a grouping of tax credits I'll talk about, and then 2 sets of rebates coming up available soon. So the tax credits are available now. So for equipment purchased and installed in 2023, you can claim a tax credit, and you have to have taxable income in order to claim a tax credit. And these upgrades need to be done to a principal residence. So it can't be like a rental property of your own, of yours or something like that. Generally, these tax credits are all 30% of the project cost, and up to these limits shown at the right here. And there are additional tax credits. I'm just showing the handful that are relevant to heat pumps and what we've talked about today. And each of them have a little bit of product eligibility that you'll want to check out. But what is very exciting is there's even a little tax credit for a home energy audit. So let's say you aren't in an area served by Home Energy Squad. You could now go hire someone and get some of the costs offset, which is great. And if you are looking into an electrified lifestyle, you really may need a panel upgrade, and that can include upgrading to safer wiring if you have knob and tube, let's say. And that's $600 going to that. Insulation and air sealing. I'm just going to put another plug in there. Please be sure to tighten up your home and insulate it before adopting an air source heat pump for heating. But $1,200 just in the tax credit for this. There'll be more money on the next slides. Just you wait. And then heat pump heating and cooling, $2,000, and same for the water heaters. So those are the caps. Now, this is the home's rebates, and this is a whole house approach. So basically, it has to have a modeled or measured energy savings at these amounts, and then you get these rebates. And so I bring this up because this could be applied to a heat pump project or multiple heat pump items if it can achieve these amounts. And this rebate money won't be available. It's still kind of trickling down from federal to state right now on how to get the money out, exactly how much, and all the requirements. So it'll be either later this year or early 2024, but please be sure to start planning now. And this other set of rebates, the HERA, it's, let's see, Energy Efficient, High Efficiency Electric Home Rebate Act. That's what HERA stands for. This one is on that same timetable as the last slide, later this year or early 2024. And these are rebates that are going to be helpful for income qualified households. So income qualified households can get the tax credit as well as these rebates. And this is what qualifies as income eligible. If you are at, if you're less than 80% of the area median income, you would be able to claim 100% of this dollar amount over here, or receive 100% of that dollar amount as a rebate. But if you're 80 to 150% of the area median income, you'd only get half of it. So it's just meant to like a little bit of equity, just to kind of give a little more money to homes that don't have as much income. And you see a lot of similar items here as we saw with the tax credit. They broke up load, service, and wiring for some reason, but insulation and air sealing. And then the major difference is there's no tax credit for a clothes dryer that I could find, but there is this rebate for it. So that's kind of an interesting difference. And the amount for that air source heat pump heating and cooling, though, up to 8,000 is quite a nice addition to help cover a project cost. And CERT has a whole website on the Inflation Reduction Act, what you need to know. You can actually find it right from our homepage right now, just on our homepage. Scroll down, it's the first major posting. The last piece of resource, one more resource you can get into is the latest and greatest since I think November or December we launched this, the heat pump advice column that I've started. It's called Ask Alexis, and you can just come on in and see different Minnesotans' questions and my answers to them. Sometimes they're a conglomeration of a couple people with a similar situation, and then I turn it into a generic Q&A. But it is, you know, real stuff. So I just did one on heat pump water heaters that talks about a lot of the stuff I just shared. There's a whole bit on home energy assessments and switching, you know, basing on, you know, how old your equipment is and when to switch things out. So it's all in there. You're welcome to check it out. And I am done with my presentation now. If let me see if I'm gonna, I think I'll stop sharing if that's okay. And I can share again if folks have questions. I'd love to be able to see everybody. Sorry, let me say the question out loud. Can heat pumps be installed below grade, for example, 6 feet, in a space designed for it and allow ambient airflow to leverage the soil temp moderation, perhaps linked to subsurface set of large conduits? So kind of a combo brick, you're thinking of like ground source heat pump and air source heat pump, maybe.
That's right. Mm-hmm.
Yeah. So I haven't heard of that yet, but I imagine the technology would lend itself to a combo of ground source plus air source. The idea of say putting it down in I'm almost picturing like an egress window, right? Like but a bigger space than that, almost outside your home. The heat pump is down in there. That's an interesting idea. I mean, I know when you install a conventional AC, they just say, oh, make sure you have, you know, 2 or 3 feet of air space all around the unit so it can access the air. I have heard, so I attend the energy design conference up in Duluth on a regular basis, and I hear from the presenters on air source heat pumps up there. And sometimes they're definitely being mindful of that outdoor unit being placed not on the prevailing wind side of a home. And it's for that reason that can really chip away at the efficiency you can achieve. And with that, I've heard of them even talking about building, little walls, or not walls all the way around it, but yeah. And then the other thing I have also, I don't have a solid answer for you, obviously, is in multifamily projects, they have put them in the parking garage because it is kind of temperature is moderated a little bit. So I haven't seen that done yet. I don't know if, what a contractor would think about that or anything, but.
The reason for the question, if I may add, is that my wife and I, we live in a 2-story earth home. So all sides except for the south facing side are buried into a hill. And so we will be doing some upgrades, and we will have the opportunity essentially to install some of that type of infrastructure. That would place the heat pump on the north side of the building, and it would be protected from the prevailing winds. So it's just a curiosity whether or not that would be something that heat pumps, today's technology, heat pumps could accommodate.
Yeah, the one thing that's popping into my mind, and I didn't say it super clearly on the slide, I should have, is in Minnesota, because we get a decent amount of snow. We need to make sure if we're going to be using heat pumps for heating in the winter, that it's installed above an average snow depth. So this idea of it being subsurface, I guess you'd have to find a way to manage the snow component there. But even at grade, they want it installed, the shortest I've seen is 6 inches, but it really should be in the metro area, about a foot off the ground at least. And even then, like a year like this, you might have to shovel around your heat pump unit to make sure it's got the air it needs.
Yeah, thank you.
Alexis, I would just add, can I add one thing to what you're saying?
Yeah, please.
I would just add that I think it's really important, not only for the snow falling, but for the defrost cycles. When you start using these heat pumps, that's another thing that Alexis didn't touch on. Your presentation was amazing, but the heat pumps defrost, and Alexis, do you want to unpack that a little bit?
No, thanks so much, Jeff. That's an excellent point. That's another factor to take into consideration on where you install your outdoor unit, because I don't know if you guys have ever tried to run your dehumidifier too early in the spring in your basement, and it's a little cold, and you go down there like it's not doing anything. You look at the back and the whole coil system's just crusted with frost. And I had a really old dehumidifier in my basement, and that doesn't have a defrost cycle, right? So it was not performing anymore. Now these air source heat pumps are kind of doing the same thing outdoors. And especially in like this 20-degree temperature zone, they do frost up quite a bit. There's a lot of available moisture in the air to frost up on the coils on the outdoor unit. And so all it does is it runs a little thermal resistance, melts it off, and then it's back off and running. But when it's melting that off, you have a condensate water that needs to go somewhere. So it might need, in that case, brick, a pump, but now we're talking about an outdoor pump that might freeze. It could get a little complicated there to get it out of a subsurface space. For units that I've shown today where it's kind of above grade, you just need to be mindful of where that condensate water is going. You don't want it running across a walkway or your driveway where you're going to be, slipping and falling in the wintertime. Let's see what else the chat box has here. Some folks were sharing the Home Energy Squad link. Thank you very much. Do heat pump water heaters cool the air around them? That is, will they make the room they're in cooler? Anna, great question. And the answer is yes. They do need to, they are pulling heat from that air to, use in the, to heat the water. And that study, the cost savings that were noted are taking that into account. So there were still savings on the whole, net savings, even with the little bit of extra the furnace is running for just that space. And part of it is this efficiency of heat pumps. So in the water heater situation, let's see, how do I want to talk about this? I haven't mentioned tonight the coefficient of performance, but that's basically the metric for air source heat pumps efficiency. And they are, you know, for an air source heat pump that's heating and cooling your home, it can be on average for the year 1.75. So it's like compared to a natural gas furnace that's very efficient, 95 or 96% efficient, is a coefficient of performance of 0.95. Okay, so we're already looking at it's that vending machine analogy I gave earlier. You're getting more units of thermal energy out than the electricity you're putting in. And so that's why on the net, you know, we get savings there, even though it's kind of robbing a little bit of air heat from your basement. It's able to turn that into so much more heat in the water heater than what was done before. I hope that was a okay enough answer for that, Anna, but let me know if you have any more questions about that.
May add an analogy.
Sure.
Now, with a vending machine, if you shake it, you can get more out of it. Do heat pumps work like that?
Well, some of like what we talked about already, making sure you're not placing the outdoor unit on a prevailing wind side and chipping away at the efficiency there. And yeah, I mean, just kind of optimizing its installation, I suppose. Brick would get you the extra efficiency.
Alexis, I'll add to a little bit if I may. I'm
Mhm.
living with a heat pump water heater for 2 years now, and I think I've the temperature variation on the space around the, you know, I think what you said before was really good on the 700 cubic feet. I think that's a general rule of thumb needed for one. Yes, it cools the space. I've heard 1 or 2 degrees is something that would be measurable, you know, a 1 or 2 degree variation. In my case, quieter than my natural gas direct vent water heater. So, you know, many people think they're noisy. No, actually, I've been living with it for years. It's quieter. So sound is so interesting. But I think the temperature, it hasn't affected comfort at all in my application. So I'm not doing my laundry in my mechanical room. If you were, it could be a consideration, but 1 or 2 degrees is something that I've read. And I think that's accurate.
Thanks, Jeff. The next question in the chat is about the difference in efficiency of variable speed versus regular heat pumps. And I don't have like the graph that I want to support what I'm about to say. So I may not be able to answer this quite as well as I want to. And in this case, Hobie, regular heat pumps.
I just wanted to know
minutes.
why would I use a variable speed?
Yeah.
I'm assuming it's more efficient.
It's about it is more efficient, so it can run at a single stage heat pump means it's running it's capable of running at 1 speed essentially. And so that means its size is set to that size. So when we have a air conditioning units, you're used to the tonnage. Air source heat pumps are sized similarly. So let's say you have a 2-ton air source heat pump, single stage. It's going to be able to operate at 2 tons. You know, it's going to be able to have that capacity, and that's kind of it. And you might need, certainly if you're trying to use an air source heat pump to cover a lot of your heating needs, you need quite a bit bigger size than you would need for your cooling because of our temperature differential around the comfortable temperature we're looking for. We only need to cover a little bit of difference in the summertime compared to a lot of difference in the wintertime. So we need a much larger sized air source heat pump to accommodate that. So a single stage heat pump would only get us efficiently a little away from our comfortable zone. And that is why it really depends on your overall goal. So if you want to keep things cost affect, the same cost or cost effective, then you could certainly go with a single stage heat pump and only run it down to 40 degrees outside when it gets about that cold, and switch over, and then you've got the efficiency is going to be just fine. The variable speed gets you a wide range on your sizing, not too wide, but maybe up to 1.5 tons. You might be able to now have something that can cool 2 to 3.5 tons, and it can kind of change. It transforms into a bigger capacity unit in the winter time. It's able to give you more performance in the winter time, let's say, with the variable speed, because it's able to straddle go faster or slower and change its capacity.
Thanks. I just want to let you know that on my office wall, I have pictures of my grandkids and then my mini split.
Oh
A
my,
picture of my mini split. So
wow, I'm really
I like it. I mean,
speaking
it's
to
great.
a knowledgeable crowd tonight. Tim, you didn't warn me about this.
I would add one other thing that I'm working at a program. Right now I'm in Decatur, Georgia, but I'm working on a program down here, and all of the incentives and some of the rebates are based on tax credits. And that's great if you have a large taxable income that you want to offset. What I'm seeing now is, if you know what a SEPA agreement is for solar, where somebody installs solar, like a community solar installation, but you're not, the city doesn't necessarily pay for that. An outside company pays for it and sells the electricity to the local community. And in a sense of energy efficiency and electrification, there's a company called Block Power, because I'm looking at converting my whole house to electric here, and that could run $15,000 to $20,000. Now, if I don't have a lot of income to offset that with, it might be easier for a company to say, we'll do that. We'll essentially lease you the equipment so that you don't have that upfront cost. And we're going to see that I think in this industry. Sealed Inc. does it in upstate New York for weatherization, and Block Power is starting to do it for electrification, which makes it available to the ends of the spectrum that don't need that tax break, let's say. Maybe you want to do it for your school system, for example. Anyway, just a comment. Thanks.
Yeah, interesting, Hobie. And we were talking about the different kind of incentives coming. So the tax credit is like currently available, but then those rebates will be available down the road. The idea is that there's a little something for everybody. So if you have a taxable income, you have a tax credit. And if you kind of are a little lower income and can't achieve all the benefits you'd want tax credit wise, you've got the rebates.
Alexis, can I have one more question on Hobie? Hi, Hobie. Good to see you. On the variable speed, I'm just going to add one more word, because I think it's an important word. I don't know if you've mentioned it, Alexis. Inverter. I think it's a really important, that to me, that when I think cold climate, I think inverter. So I think that just not only improves comfort, Alexis did a great job unpacking that. It's steady, constant, but I think it also really improves the longevity of the equipment. So these things are always on, they're always operating, and they'll last a lot longer, because from my understanding, the starting and stopping of the equipment is really hard on it. So I just think of a New York City cab driver versus someone that's a smooth driver. Hope that helps.
Yeah, that's a great analogy, Jeff, on how it adds to the efficiency too, going with a variable speed. I pulled up this a bit more technical page just so that you can see some of the details around this. I pulled it up because I thought it had the inverter compressor on here, Jeff, but it looks like I took that piece off, kept it with just variable capacity. But this is some additional information. This is that annual COP value. So this is what we mean when we say cold climate air source heat pump. You can look any of the equipment up on this NEEP list and confirm that the piece of equipment that your contractor is speccing for your project is a cold climate one, if that's the level of performance you're looking for. And you want it to be sized to meet 100% of the home's heating load at outdoor temperatures of 10 degrees or less. And that sizing means they should be running heating load calculations for your home. They should not be simply sizing it off of your current AC size. If they do that, find another contractor. Do not work with that contractor. Okay. And they also shouldn't be doing it with a rule of thumb. They shouldn't be sizing it slightly up. They should be running new load calculations for you. And I'm going to stop my screen again. Philip, you have your hand up and you have a very technical question in the chat that I am going to have to pass on. But go ahead. Oh, you're still muted, Philip.
It was a comment about putting the AC unit in a kind of a well, and I was worried about recirculation for the gentleman, and so I kind of put a half an answer in there that you still got to get air across the coil to get the heat transfer you need. But my question is, I've got a 32-year-old air conditioning unit that I'm keeping as long as I can. It's undersized, so it dehumidifies better. And then I've got a 15-year-old furnace that's still running. And I'm thinking about, now you've kind of lit the fire of doing a hybrid where I buy a air source heat pump to act as my, and then put its coil above my existing furnace. I presume the CERT site has some good information on how to do that. I'm thinking the room above the furnace may not be enough to throw in a heat pump coil. Are heat pump coils bigger than typical AC coils?
Nope, they'd be really similar. In your case, you'd probably be replacing the AC anyways, so they'd be changing out that A coil, and they'd be removing the previous A coil for the air conditioner and putting in all compatible equipment for your heat pump system. I think you're in a real optimal spot here, Philip, for air source heat pump in your life, because you've still got a furnace that's an age that is gonna keep operating, and as you reduce its operating hours, it might even last longer, so that's kind of an appealing aspect of offsetting some of your heating with the air source heat pump. And if
I wasn't really considering it till right now.
Oh, okay. Yeah, and so you'll just want to keep an eye on what your budget is for the project and what your goals are. And so if you are kind of budget conscious, you could definitely go with single stage heat pump and keep, just using that for your
No, I would go inverter for sure.
Yeah, then you can go at least one level up to variable. If you want to go all the way cold climate and kind of get ready for an all electric home in the future when the furnace goes kaput, that's an option too. So what that involves, that's in the St. Paul story I mentioned earlier. When you go all electric with these, you now have your air source heat pump that's doing the compressor to bring in heated value air. And then if it's too cold, you have an electric resistance. It's called a plenum heater. It's an extra little bit of heating in the ductwork, and it's like 10 kilowatts of energy. And a clothes iron is about 1 kilowatt. So you can picture like 10 irons lined up in your ductwork, and that blasts on when it's like really cold. So that's why it's a little you don't want to have to turn to that unless you have to, because it's a big draw on your own home and the grid and everything. But that is how we're going all electric right now in the Twin Cities.
Okay. Can you talk a little bit more about insulating your house? I've got a 50-year-old house with just 4-inch walls and probably 3.5-inch bat, which is pretty lousy and sounds like I have to budget foaming my walls or something.
Do you have a need to take care of your exterior surfaces by any chance? Your siding or your roofing?
Unfortunately, I just did it 10 years ago. So yeah, I don't, but I'd be
Yeah.
willing to, yeah. Okay, anyway, maybe you remove the batting through the interior walls rather than the exterior?
I might not have the best answer for you on that right now.
I might
Yeah,
have a
go ahead, Alex.
better.
Thanks so much.
I just started with CE, Home Energy Squad, so I'm just learning everything now. You might be able to, depending on what type of siding you have on your home, you might be able to take, if it's like vinyl siding or something, you might be able to take a couple pieces off and have them go through it that way.
Yeah, it's cedar siding. And we just painted it last year, so.
But would you have to remove the batting in order to add?
Well, maybe you wouldn't have to remove the batting, would you? You just foam it up. Okay.
That's what I don't know. That's what I would need to check with an insulation contractor to know for sure on that.
Okay.
But even just
Philip,
sealing
may
up the
interject.
home nice and tight goes a long way, just getting the home tight. Go ahead, Brick.
oh, I'm sorry, there's a hand up from,
Oh, I wasn't sure if
Alex.
you were trying to add into that insulation
No,
conversation.
my question was
Mhm.
for using like an ecobee, how wouldn't like an ecobee communicate with your furnace and a heat pump?
Yeah, just so everyone knows, ecobee is like one of those smart thermostats. So it's just like the latest and greatest in thermostats. So that is, again, that's going to be very equipment specific and brand specific. So, the brands are like Bryant and Lennox and Mitsubishi, and, those are your Trane, those are your common air source heat pump brands. And so all of them are the air source heat pump installer is going to know their equipment the best and what's compatible. And so it might mean a new thermostat, but certainly I believe they're compatible with smart thermostats. It just may not be compatible with that particular smart thermostat. So depends. Any other questions?
I was gonna add, Philip, that a friend of mine, he actually, he did have to put new siding on. And what they ended up doing is they actually added a 2x6 wall in the exterior of the home to be able to allow for it increased insulation thickness. 2x4 obviously is a pretty limited space to be able to insulate, but that then minimizes the amount of space loss inside your home.
Thank you.
I do have a question about the 35-degree temperature cutoff. I've talked to a few people that have had mini heat pumps installed, and they said 20 below, they're still feeling heat coming out of that thing. And so is it just so inefficient that they might be getting heat, but it's costing them a lot more to do so?
I am not sure. That's stretching my
Okay.
technical knowledge on it. I'm pleased to hear that, but I'm wondering what you're wondering. Is it doing it, but at some great cost?
High energy cost, right? Yeah.
Yeah.
It's no longer,
I'm not sure.
Don't they publish something like the COP of 1 occurs at like 17 degrees or 10 degrees or 0, and that's your crossover point?
Yeah. So again, my colleagues and friends over at Center for Energy and Environment, where Home Energy Squad is hosted out of, they have done the research on the air source heat pumps, and so there's many more graphs that would supply more of the answers to what you guys are asking. But there is one where they did the It's just, it looks like a bunch of dots all over the graph to kind of show the coefficient of performance on every single day of the fields, the duration of a whole winter that they had the air source heat pump in the field. And yes, you can draw, basically put a trend line approximately on that cloud, but it shows you how it drops off below 5 degrees. It's getting lower and lower, but I don't know. I can't give you specifics on that right now.
Yeah, Isaac actually gave us a short presentation on that several months ago. He
Oh,
did say that it did become much, much more inefficient and it costs more to run. So I think
Yeah.
that's why they set the 35-degree mark, because below that it costs more.
yeah. Oh, I'm
That
glad
makes
you
sense.
had Isaac out. I'm probably more of the show before Isaac's level of information on air source heat pumps, more the introductory show.
I don't think so, Alexis. You're nailing it. You're doing great. This is. Can I make one more? So I'm involved in the heat pump supply chain. I own a distributor, but I want to make one comment on ductless. There are so many exciting things happening in the industry right now because ductless is almost a word that we're moving away from. I think mini split's good, but I think the side discharge inverter heat pumps are starting to take over the whole home. So we're starting to see that. Somebody else commented on the inverter heat pump over the furnace. That's becoming very normal now, where these worlds are. I mean, all the Mitsubishi has an IntelliHeat, Carrier Bryant has a crossover, but it's pairing these ductless, or side discharge inverter outdoor unit with a traditional system. And I think the kicker for the IRA is having these things be rated through HRI to grab the rebate. So there's all these worlds are kind of coming together. So I have a hybrid home, so I think that's really interesting. It's really different. So the side discharge ductless heat pump may work in a duct configuration for your home. In fact, I know it would.
Yes. Yeah. Thanks for bringing that up, Jeff. I know I was kind of saying this is what we've been seeing, but even last summer, I did a little outreach at the state fair, and we were on the fence of whether or not we should bring, that we should even have the unitary unit there on display, the one that looks like a conventional AC, because that we might be moving away from that pretty soon here and only have side discharge. And in part, correct me if I'm wrong, Jeff, but because they achieve much greater efficiencies. Is that right? Is that why we're turning to side discharge? And when we say that, guys, that just means the fan is facing on a side instead of up and down like conventional.
Yeah, yes, I think so.
Yeah. Yeah, and more, I think some manufacturers are trying to make units that are compatible with indoor air handlers. So that's where you just want to ask your contractor if that's really important to you, to preserve the equipment you have because you just put in a brand new furnace. They might be able to work with that. But if you have a very old furnace, that there may be compatibility issues and you need to upgrade the air handling equipment inside the home. Brett, do you have another question?
I do. Are there certain types of certification licenses that you would recommend that we seek when we are seeking out contractors?
So that preferred contractor network is a limited pool of people, but that is the one I would say, if you can get someone who is on that list to do your job or get you your bids to consider, which one to go with, that is where I would start. Absolutely. Because those folks have been, kind of screened to have the qualifications they should have, but then they've gone an extra mile and they've taken Minnesota specific training on air source heat pumps and the sizing and a quality installation.
Thank you.
And there are other certifications. I just don't have the names of them off the top of my head right now, but
I like to say the PCN is the group that won't talk you out of a heat pump, because many contractors will.
PCN is short for that preferred contractor network. Exactly. Yeah. And that's, I mean, if if they're trying to talk you out of it or just saying it won't work, I mean, don't try to convince them. You don't want that kind of contractor doing your project. You want them to be knowledgeable. And Jeff, I'm realizing you and I were emailing earlier this week, in
Mhm.
fact.
Right. Yeah.
I'm now putting a name together from email.
Good. Thank you.
Yeah, thank you so much for your additions tonight too, and everybody, all your great questions. Hobie, did you have another question?
It was just a statement. Where I live, we get a $40 to $50 a month hookup charge for, I'll call it fracked gas, because I don't like using the term natural gas. So the idea here is to cut the umbilical cord to the gas company entirely. That means that you've got to look at heat pump, water heater, dryer, and also the induction or electric stove in some way, shape, or form. But when you look at that, that adds, a significant amount to the value of the changeover over a period of 5 to 10 years. So just, I don't know what it's like in Minnesota. I haven't looked at the bill there. So
Yeah, I don't know about that charge on gas bills. But you're helping remind me of a point I wanted to make, Hobie, and that's the electrified lifestyle I was talking about earlier. Couple things. These Inflation Reduction Act money, it's going to be available for 10 years. So you could be planning out your electrification over time. And please do them in the right order, which is tighten up your home, insulate it if you can first. That is very important before switching out any of your heating systems. Then work on heating. If you really need new windows, that kind of thing, exterior doors, there's some money for that as well. Do that part. Get your shell entirely buttoned up. Then you can look at heating and cooling maybe next. And then the water heating, the clothes dryer, and then the cooktop after that. And the beauty of it lasting for 10 years here is you can make the plan and start figuring out, okay, what do I want to line up first and take care of in the first few years, and then give myself a break and then get back at it before the 10-year window is over. Jeff, did you have another comment or question?
A rebate comment. So rebates are coming, right? They're part of the IRA. They're part of the preferred contractor network. The MN Air Source Heat Pump Collaborative site has a great rebate map for your local utility rebate, but also we're starting to see in Minnesota, there's citywide rebates for electrification. So I've just heard recently, and I'll put one in the chat, I don't live at Edina, I live in Golden Valley, but Edina, St. Louis Park, and the city of Minneapolis all have an additional rebate. So these rebates can be stacked. That's pretty exciting to me. There's so much money to make these things, to make it go.
I just added in the chat Energy Star link as well, and that's got a nice, I think it's the most user-friendly version of understanding the tax credits for all the different equipment. And you'll see there's tax credits for things I haven't talked about tonight too, like geothermal and some solar, some things like that. Yep, Julie's chiming in as well about checking with your city about more rebates. Nice. So Shorewood has some as well. Excellent, Julie. Great to hear. Any other questions or comments?
I have just a comment. I think this idea came from Hobie, where what we'd like to do is somehow get a manufacturer independent trailer where we have some heat pump equipment on it and go around to the various venues in the whether it be a county fair or a parade or whatever, and just explain heat pump information to people rather than, so it's more widely known rather than those of us that are interested in it. And I was wondering if CERT had any insight into that, or I mean, it might take a little bit of funding by us to develop that.
And you guys are
Right.
just mainly in the metro area, is that right?
Yeah.
Yeah. There's two thoughts that came to mind, and that is the state fair. So the Department of Commerce is they help with putting on a whole energy component in the Eco Experience building. And last year, kind of at the 11th hour, we were able to get just a couple pieces of demo equipment on air source heat pumps, and they were a total hit. Everybody wanted to come over and look at them and talk about them. Due to the space area there, it was a little tricky to be vendor agnostic, or even like include a lot of different distributors that provide different brands of equipment. And so I'm trying to think of what a traveling unit would look like that is brand agnostic. When we were working on that for the state fair, I did learn that they have a badge, like basically the brand can come off, I think. But I don't know how that would work, because in part, you know, to get that equipment, you'd either want to pay for it in order to have the flexibility to maybe get the badge off, or some of the distributors might be willing to donate, knowing the product, some of the product names are out there, you know. So that's kind of an interesting idea. And where I'm going with that too is, I think the state fair, that the Department of Commerce has this idea of more mobile demonstrations that then could go out on tour across the state, not just be at the state fair. So there might be an opportunity for partnership there. So that's something to keep in mind, to figure out, you know, how we can have this education be a little more 3D.
But I think we should give Alexis a great hand right now, a virtual hand. Thank you. And we have some good news. This training that Climate Realities for Climate Reality Leaders and Refresher course in April is going to focus on the Inflation Reduction Act. And so we'll learn more about, I know, the rebates and stuff like that, and exactly what the latest details are, so we can spread that work too. So please sign up. And Jason, you had some announcements you wanted to make too. And
really, I just kind of wanted to again, thanks Alexis for a great presentation, and kind of talk about our next membership meeting. Should be coming up on March 9th. Join us then for a presentation from Jim Doughton from the city of Minneapolis on their carbon sequestration program, which uses carbon negative actions to remove and sequester carbon through biochar, a soil amendment that helps sink carbon into the soil and keeps it out of the atmosphere. So be sure to join us then and learn what the heck all that means. I just want to say, on behalf of the leadership team here at the Central Minnesota chapter of the Climate Reality Project, thanks for attending.